Okay, we're on the back of day 2 notes, and we are going to talk about the last type of factoring for today, and it is called factor by grouping. Remember that the first type of factoring you should always check for is greatest common factor, so we're still going to check for greatest common factor. In number 13, the 15 has no variables, and 2 is the smallest number, cannot be pulled out of all the terms, and so there is no greatest common factor. It's also not a difference of two perfect squares. You'll notice it has a completely different format than the D2PSs on the front side, and therefore it must be our third type of factoring. So it's called factor by grouping. What we're going to do is we're going to take two brackets, and we are going to group the first two terms and group the last two terms. Out of the first group, we're going to go ahead and pull something out. Remember that you're not looking at the second group at all, just the first group. And in the first group, there is a greatest common factor of 2x squared. Left over would be an x minus 3. Out of the second group, now ignoring the first group, there is a 5 in common. And this right here means that I put a plus sign right here. Then I put the 5. If that was a minus sign that I circled, then I would have put a minus 5. Okay. So parenthesis, and there will be an x minus 3 left over. The cool thing about factor by grouping, it's very checkable. These are supposed to match. Therefore, we pull out the x minus 3 as our first factor. If the x minus 3 has been pulled out, the only things that are left are what I call the guys on the outside, the 2x squared and the plus 5, and we go ahead and push them closer together, and they become our second factor of 2x squared plus 5. And that is how you factor by grouping. So let's try the next one. In the next one, it looks like we have nothing to pull out for a greatest common factor between all four. This a squared doesn't have any numbers. This 6 doesn't have any letters. So there isn't anything I can pull out of all four. It does not have the format of a difference of two perfect squares. And so I'm going to try to factor by grouping. Out of the first group, I can pull out a 4a. Left over would be an a squared plus 6. Out of the second group, doesn't seem to be anything in common. But I know that we talked about this in the first one, that if that's a plus, we write a plus. If it was a minus, we would write a minus. And if there's nothing in common, you have to write something. And this is the one case where we do pull out a 1. Okay? And I'll show you why that we need that plus 1 there. Left over would be an a squared plus 6. And again, the cool thing about factor by grouping is that these are supposed to match, and they do. Therefore, they become my first factor in my answer, a squared plus 6. Guys on the outside, we squish them together, and they become my second factor, which is 4a plus 1. And this is factored. And again, why that plus 1 was so important. If we did not put that, it wouldn't show up here. And it needs to be there, and so that's why it's important to put it here. Okay? I'll move my screen up. Next one up. Again, anything in common? No number there, no x's there. I would say no. Does not have the format of a D2PS. So I'm going to go ahead and do factor by grouping. Out of the first group, I can pull out x cubed. Left over would be x squared plus 4. Out of the second group, it's got to be a positive, and there is a 2 I can pull out. Left over would be x squared plus 4, which is perfect because these match, which becomes my first factor. Guys on the outside, squish them together, x cubed plus 2. Neither factor can go again. We box them up. This one's done. Number 16, anything in common? No letters there. 2 cannot be taken out of all four of them. It's not a format of a D2PS, so I'm going to say factor by grouping. Out of the first group, I can pull out an x squared. Left over, 3x plus 2. Out of the second group, because this is a negative, I have to make sure that that's a negative, and the largest number that goes into both is 9. Left over is 3x, and this is going to have to be a plus sign, so that if I distribute the negative 9, I get the negative, and it's a 2 to get the negative 18. Again, these match. So 3x plus 2 is my first factor. Guys on the outside, squish them together for my second factor. And this is something we're going to have to start watching out for. This factor right here, x squared minus 9, do you recognize it? It's a difference of two perfect squares. And because I can go ahead and factor it, I have to. Factoring is pulling it apart till you can't pull it apart anymore. Because I can pull this factor apart, we're going to have to. When we pull a D2PS apart, just like we did on the front side, we square root the first term, which is x. 1 is followed by a plus sign, 1 followed by a minus sign, and the square root of 9 is 3. This factor is not factorable again. It just drops down into my answer, and it must be there. Now it's factored completely. 17, what do you notice? Ooh, that's a lot of terms. Are a lot of terms in 17 and 18. And again, your procedure shouldn't change. Is there anything in common between all 6 terms that you can pull out? The answer is no. Not a difference of two perfect squares, so it must be a factor by grouping. And this is just one where there is 3 groups instead of 2 like the last ones. Okay. One thing I want to point out, do not reorder the terms. You might want to. These ones are actually in order, so I would leave them. I would always leave them. The other thing you don't want to do is there are 2 sets of like terms. Don't combine them. All right? Don't combine them and don't reorder them. You see 6 terms, you're asked to factor, just go ahead and group, group, and group. Out of the first group, we can pull out x squared. Left over, x plus 2. Out of the second group, a positive 3x. Left over, x plus 2. Out of the second group, it has to be a minus and 5. Left over, x plus 2. Match, match, and match. Therefore, the x plus 2's come out because it's common. It's like a new greatest common factor. Guys on the outside, squish them together. You get x squared plus 3x minus 5. And that does look like a trinomial. However, it is not a factorable trinomial. It is impossible to find numbers that multiply to negative 5 and add to 3, which we haven't reviewed yet. We will review it tomorrow. But just to let you know, it's not factorable again. All right, number 18. Nothing in common. 6 terms. Should I reorder them? No. Should I combine them? No. Just group them. Out of the first group, we can pull out an x squared, left with x squared plus 5. Out of the second group, a positive 7x. Left over, x squared plus 5. Out of the third group, it has to be a negative and a 4. Left over, x squared plus 5. X squared plus 5's get pulled out to become your first factor. Guys on the outside, squish together to become my second factor. And again, that's a trinomial. However, it is not a factorable trinomial. It is impossible to find numbers that multiply to negative 4 and add to 7. All right, so that one's finished. One last one. Oh, we got a lot of variables. All right, first type of factoring we should check for, greatest common factor. Is there anything I can pull out of all of them? Let's look at numbers. Can't pull a 2 out of a 9. Can't pull a 3 out of a 2. I can pull out an x. I can also pull out a y. Left over 6 x y negative 2 x negative 9y, a positive 3. Okay. All right. And so now if I look, I'm going to say that that might still be factorable by grouping. And so now we're going to go ahead and group the first two and group the last two. What happens to this xy is I don't want him to get in the way, but I also don't want to forget him because he has to show up in my answer. So I'm just going to drop him down there. All right, out of this first group, I can pull out a 2x. Left over would be a 3y minus 1. Out of the second group, I can pull out a negative 3. Left over is a 3y minus 1. And there, those match, so it worked. And so 3y minus 1 is one factor, and 2x minus 3 is my second factor. And I'm just going to go ahead and drop this down, or I guess I could have brought the xy up and then boxed it in. I guess it doesn't matter. And those are my factors. And I'm finished. Okay, more factoring tomorrow.